My microphone is off. There we go. Now the microphone's working. Haha. That means I'm going to need to re-record my algebras. Love it. At least I discovered it early. So we're going to start with drawing our picture. I'm going to come over here. I've got my port, which I'm going to label it as a point P. And we're going to just kind of give ourselves a little vague north-south here so that I can place my other boats. I know that boat 1, my first boat, is going north 25 west. So it's going north and west this way at an angle of 25 degrees. That's what it means for it to be going north 25 west, is it's headed this direction. We're wanting to know what happens to these boats at 4 p.m. So can we find out how far this boat went, what distance it went in at between 1 and 4? So let me see, purple. So this is, purple boat is going 22 miles an hour. So how many hours has it been driving between, or boating? It's been going for 3 hours, right? If it is going 22 miles an hour, how far did it go? 66 miles. So this purple line is 66 miles long. We're going to do very similar sketch for our other ship. We've got another ship sailing north 65 east. So it's going north from the port as well, and it's going east. So it's going this way. And I'm making it shorter. This is 65 degrees this way. This boat's going a little slower, so I made my line a little shorter. Because this boat's only going 20 miles an hour. And it left a little later, so it left at 1:30. So how many hours did it travel from 1:30 to 4 p.m.? It did travel 50 miles, but that wasn't the question that I asked. Yeah, 2.5 hours. And if it's going 20 miles an hour, we know that it went 50 miles. So that's the picture from the paragraph. Okay, I'll zoom it in just a smidge so you can actually see the whole thing and the story. Close. What our question is, our first question is how far apart are they? What is X?
Wouldn't it be 60 instead of 50?
It's,
20 times 3.
they went 2.5 hours.
Oh, okay.
They started at 1:30. But no, yeah, 100%. It would have been 60 if they'd gone for the full amount of time. But they left later. They got stuck in the port. Okay, so what's our instinct on trying to find X here? For trying to find this distance?
So right triangle.
It's a right triangle. This angle right here, 25 plus 65 is 90. So this is a right triangle. Which means, what is another name for this side?
Hypotenuse.
The hypotenuse. If I know the length of a leg, and I know the length of a leg, how can I find the hypotenuse? I mean, tangent, but the Pythagorean's way easier. Well, don't make yourself do trig functions when we've got squaring. Squaring is so much easier. All right. So we're going to take both of the legs. We're going to take 50 squared plus 66 squared equals our hypotenuse squared. Which I just put as an X because I made choices. Oh, I left my coffee.
45,000. 36,500.
Oh, you're just doing our squaring. I'm like, you're right. Just shouting out random numbers. But I figured it out eventually. 2,500 is 50 squared. You're right there. 66 squared. Utilize the tools at our disposal, yo. We got calculators. 4356 equals x squared. So we add those together. 6,856 is x squared. So what's x? Square root of that. More specific. Not 17. And they did say estimate the distance, so we can round it there or we can round to the nearest mile. I don't particularly care. Either way, it's an estimate because we're getting it as close as we can. 82.8 miles. So the length of our hypotenuse is 82.8 miles. And that's the first part of the question. First part. Thus why I wanted to do one of these together, because they asked a whole nother question here. Because now what they want is they want us to come over here to this purple ship and find the bearing to the other ship. So we want to figure out if purple ship needed to head directly over to green ship, what bearing would they turn? So we're going to set up another north-south axis here to see if we can figure out what it is. What we need to know is this angle here. That's what we're looking for. I'm going to put that a little farther away. So we want to know what this angle is. I'm going to give these a couple of names just so that we can talk about stuff. So I'm going to call this one alpha and beta. Because we have two little baby angles in here. I've got alpha and beta. So if I find both of them, we can figure out what yellow is. What can I do to find either alpha or beta? Alternate interiors. Which one do we know? Yeah, the alpha. Because alpha is an alternate interior with what angle? 25. So alpha is 25. These guys are alternate interior angles, so they match up. So that angle is 25. How could we find that beta angle? Is beta in our triangle? Could we maybe use a trig function to identify the measure of this angle? Which one do we want to use? It doesn't really matter. We have lots of information. I was going to say I'm gonna try and avoid to work with the decimal answer because, ew, let's not make trig functions worse. So if we're gonna work with both legs, which function are we gonna use? Tangent. You can absolutely use sine, but you're gonna have a decimal in it. That's fine. You can absolutely do it. You should get the same answer. So we're gonna do the tangent of beta. Tangent of beta is what? 50 over 66. But I don't want the tangent of beta. I just want to know what beta is. What are we going to do? The inverse. Beta is the inverse. Except I tried to write tangent and say inverse at the same time, so I put an I in it. Inverse tangent of the fraction 50 over 66. We're going to take the inverse of both sides. So what is the measure of beta? We're going to round to the nearest degree. 37 degrees. So if alpha is 25 degrees and beta is 37 degrees, how big is angle yellow? Yeah. Combined together, this should be 62 degrees. So what is the bearing that purple needs to take? So from here, what bearing does it take? South, 62 east. Yes. South, 62 east is the bearing from the first ship to the second. So like I said, we can do all of this, but figuring out all of those pieces is obnoxious as all get out. Yes, dear. Yes. What's up? Because combined together, alpha and beta, to get this whole angle here. Alpha was vertical angles with 25, so they matched. Beta we calculated down here to be 37. Combined together. Added them together. The 25 and the 37. Okay? And theoretically, to answer the other question, it could be, theoretically. Not usually quite that much of a jerk. Usually. Okay, the next one is significantly nicer. This has one teeny tiny tricksy spot, not a gargantuan tricksy spot. Okay, and there's one also very much like this one on the homework. I just didn't work down the number of it. But there's a kite problem. So, but this is different because now it's a child, not an adult. So it still has the same tricky part as the one on the homework. So we've got a small child. Aren't they special? Holding a kite. Kite. And they are holding the string 3 feet off the ground. What we want to know is how high this kite is. I know they're holding it at an angle of 45 degrees because that's what they tell us here. So I didn't draw a very good 45, but I know it. It's here. What's up?
You said it's an ugly person. I would take that. You said you could do better.
I am a fine artiste. I don't know what you're judging.
That was
And y'all have seen my airplanes. Just saying. You know I'm a fine artiste.
Nah, they look like they crashed into 9/11.
Oh, you should see my dolphins. They're beautiful.
You draw
Dolphin. Hey, give it a fin. Here, fin. There we go. Flipper. It's kind of elf backwards. I am a fine artiste. The best. My children know to not come to me if they need help with drawing things. My husband has a fine art degree. I am not the choice. All right. So we know they've let out 200 feet of string. So that means I know this distance here. That's the string. That's my hypotenuse here. And what we want to know is this height. I want to know how far the string is off the ground. Yeah. I said when I get the ground, we're going to have grass. There we go. Grass. Bless you. So we are going to use sine. I recommend sine. I mean, you could use others, but it's just going to be a lot more work to fill in other pieces. Because we know the angle, I know, or at least I want the opposite, and we know the hypotenuse. So let's find the sine of 45 and set this up. How are we going to set up our fraction over here? X over 200. And again, you don't have to use x. I just picked x because it's one we're comfortable with, and I tend to default to x. 200. So times 200 on both sides. So we have 200 times the sine of 45 equals x. Whole number. I mean, you can do 10th if you want to, but so the nearest whole number is fine. We're estimating. We're getting it close. So how big is x? What is x? It's 141, right? Is that my answer? Is that how high the kite is off the ground? Why not? Because the string is 3 feet off the ground. We got to include this 3 over here. So how high is our kite?
He's 3 foot tall.
No, he's holding the string 3 feet off the ground. It's a kid.
Oh, yeah, you're right.
That's why I changed it to child, because the one in the book is an adult, and they're holding it like, I think, 4 or 5 feet off the ground. So the kite is, that's a weird eye, but it's okay, 144 feet off the ground. This is more of the vibe that we tend to go with when it comes to things we ask you to do more on the independent side. These are questions we like to do together because holy cow, is that a lot of stuff? These are significantly more comfortable. Huh.
There'll be stuff like this on the side.
Entirely probable.
What type of kite was it?
Apparently a diamond one,
Okay.
because that's what I drew. There's all kinds of fancy kites, but I can't draw any of those fancy kites. Okay, so to ask your burning question from before, we are still going to do quiz 3. However,
Take home.
take home.
Yeah.
Okay? It's over the graphing stuff, so I'm going to pass it out now. We are officially done with notes for chapter 6 as well. So on your way out, I want you to pick up from the little tray the review. Because we're going to have for the test. There's a packet of the review for the test.
Every day I can get.
Yeah.
Okay, and we will have work days on it tomorrow and Thursday. And like you guys can work and ask questions. We can go through stuff together if you want. Or you guys can have the whole time work on your own. Either way is fine.
No, I'll be able to finish this.
So here's the quiz. And then the review is in the tray by the door.
Oh,
All right. And we are officially done with notes for Module 6. That doesn't mean we're done with the quick questions. Sorry. We are intrigued like all semester. Yes, yes.
How come 13 and 14 have so many parts?
Because we didn't want to make it a 50-question review. But we still needed you to practice stuff. And to be fair, I didn't sign it.